In this video, we're taking a look at 10 different DIY projects I built using Raspberry Pi, Pico, and ESP32. From a custom-built Shutter Pi camera and a smart desktop weather station to a mechanical macro pad and my own handheld game consoles, I brought everything to life right on this desk. From simple sensors to complex setups, everything is in this video. Before we start, don't forget to subscribe to the channel and leave a like. Let's get into it. First up on our list is Shutter Pi, a custom digital camera I designed and built completely from scratch. To break free from commercial cameras, I started by 3D printing a modular chassis. At its core, it runs on a Raspberry Pi 4, 8GB RAM, paired with a 12.3 megapixel Sony IMX477HQ camera module and a 4.3-inch DSi touchscreen. Powered by an integrated UPS HAT for fully wireless outdoor use, I also developed a custom software UI for it. I field-tested Shutter Pi during my trip to Cappadocia, and with its smooth live preview, quick focus, and impressive image quality, it far exceeded my expectations. Now, let's take a closer look at the actual footage recorded with Shutter Pi. We captured the breathtaking sunrise landscapes of Cappadocia, hot air balloons soaring into the sky, and the intricate details of the fairy chimneys in crisp 4K at 30 frames per second. With the Sony IMX477 sensor's high dynamic range, it captured sharp details and vivid colors even in early morning light. Next up is SensePi V1, a compact device designed to turn your workspace into a complete control hub. Powered by the RP2350 processor on the Raspberry Pi Pico 2W, it features a 2.8-inch touchscreen shield and a rotary encoder for smooth menu navigation. Thanks to its Wi-Fi capabilities, it fetches live weather, currency rates, and real-time earthquake alerts. T features a custom 3D printed enclosure that I designed and printed completely from scratch. Thanks to the built-in HCSR04 ultrasonic sensor on the front, it also functions as a precise digital distance meter to measure surroundings on the fly. Our next project is SmokeNode, an IoT-powered home safety node. Driven by an ESP8266, it continuously monitors gas and smoke levels using an MQ2 sensor. Thanks to its Wi-Fi connectivity, it syncs atomic time over the network and stores precise alarm timestamps in its non-volatile LittleFS flash memory, even through power cuts. Built on an asynchronous zero-delay architecture, it reacts instantly with sound and LED flashes. It also features a smart mute mechanism. Even if you silence the alarm, the safety lock auto-resets only after the gas levels clear, keeping you fully protected. Coming in at number 4 is MakerIO, a custom pad built to speed up your daily workflow. At its core, it runs on an ESP32-S3 with native USB-OTG support, instantly emulating a hardware keyboard without needing extra drivers. With its 8 mechanical key switches, you can trigger shortcuts like copy-paste or launch applications like Google Chrome with a single tap. The rotary encoder makes it super easy to adjust system volume and toggle media play/pause. Meanwhile, the color TFT display fetches live weather and NTP time over Wi-Fi while logging your key presses in real time. It quickly became one of the most useful tools on my desk. At number 5, we have a project that retro gaming fans will love, Pi Game. At the heart of this handheld is the new Raspberry Pi Pico 2, powered by the RP2350 chip. Running a custom walnut CGB emulator core, it plays original Game Boy and Game Boy Color games at full speed. I drove the 2.8-inch TFT display over a fast 60 MHz SPI bus, ensuring super smooth gameplay. In future updates, I'll be adding a MAX 98357 AI2S digital amp to deliver crystal clear 8-bit retro sound. It loads all your favorite ROMs right off a micro SD card. Since it's still a work in progress, I'll be releasing a dedicated video for it very soon. At number 6, we have a sleek desk build, SmartStation Pi. Powered by the Wi-Fi enabled Raspberry Pi Pico W, it features a 2.8-inch WaveShare touchscreen shield that plugs directly on top, keeping the entire footprint super clean and compact. Once connected to Wi-Fi, it syncs precise network time and renders an elegant analog clock UI. Equipped with a DHT11 sensor, it monitors ambient room temperature and humidity in real time while fetching live weather updates via the OpenWeather API. Thanks to its onboard buzzer and physical push buttons, it also doubles as a fully functional desktop alarm clock. At number 7, we have a project that's tiny enough to fit in your pocket, yet packed with features: the ESP8266 Pocket Retro Arcade. By adding just 4 push buttons and a buzzer to a mini ESP8266 board with an integrated 0.96-inch OLED screen, I turned it into a fully functional handheld gaming console. It comes preloaded with classics like Tetris, Snake, Flappy Bird, and Space Invaders. The vertical display orientation leaves plenty of room for both gameplay and a live score panel. Best of all, thanks to the non-volatile EEPROM memory, your high scores and volume settings are saved even after turning off the power. Plus, holding down D4 and D7 instantly exits any game back to the main launcher. At number 8, we have a custom accessory designed to level up the ShutterPi camera, a modular 3D printed tripod. I didn't want to limit the camera to handheld use alone, so I designed all the mechanical parts, joint pivots, and leg mounts from scratch and 3D printed them. Featuring an adjustable tilt head with a locking knob and sturdy multi-angle legs, it allows me to dial in and lock the camera at any precise angle. It mounts seamlessly to the ShutterPi chassis, eliminating camera shake for rock-solid stability during self-timer shots, landscapes, and long exposures. At number 9, we have an all-in-one multi-project station, the Pico 2 Kit Guide. Powered by the new Raspberry Pi Pico 2 and an HC-SR04 ultrasonic distance sensor, it merges 10 standalone builds into one hardware setup. To protect the Pico 2's 3.3-volt logic pins from the sensor's 5-volt output, I integrated a custom voltage divider circuit. Software-wise, it leverages RAM frame buffer technology in MicroPython to render butter-smooth 240 by 320 display graphics. From a touchless digital theremin and a retro Pong game to a smart parking sensor and a posture monitor, you can switch through all 10 interactive modes seamlessly using physical menu buttons. The 10th and final build of our compilation video is an absolute desk upgrade, the Pico 2W Internet Radio. At the core of this build sits the new Wi-Fi-enabled Raspberry Pi Pico 2 watts. Running on CircuitPython, it streams live web radio channels seamlessly while rendering real-time network time, date, and live weather telemetry on its color TFT display. Station selection and volume are effortlessly controlled via a rotary encoder. To overcome common embedded audio stuttering and memory fragmentation, I implemented a custom double buffering and dynamic audio mixer architecture. Paired with a MAX9 8357 AI2S digital audio amplifier, it delivers rich high-fidelity sound output. And that brings us to the end of our 10 DIY projects compilation. If you want to see more content like this, don't forget to subscribe, drop a like, and leave a comment below. Which project was your absolute favorite? Let me know in the comments, and I'll see you in the next one.